Hello, calculus fans. If you have a curve, it's actually possible to represent it by more than one different vector function. Let's take as an example this curve, r1 of t, which is t squared, t cubed. This could also be represented by a different vector function. r2 of t is e to the u, e to the 2u, e to the 3u, with different limits on u. In this case, the connection between the parameters t and u is given by t equals e to the u. So in this case, we have two different parameterizations of this curve. And if we want to compute the length of the curve, we'd actually get the same result regardless of which parameterization we use. So I would say use the simplest parameterization that you have. So in general, the length of the curve is going to be independent of the parameterization that is used. Now, let's suppose that we have a piecewise smooth curve that's given by a vector function, and that the curve C is traversed exactly once as t goes from A to B. No looping around or retracing steps. We're going to define the arc length function using this. We're going to say that s of t is the integral from a to t of the length of r prime of u du. So very important to notice our limits of integration. So this is just what we were doing when we were computing arc length, but now we're having our limits of integration go from a, which is a number, up to t, which is going to be some parameter. This measures the length of the portion of the curve between r of a and r of t. So here's the picture. You have some curve, you have r of a and r of t pointing to points on the curve, and then s of t is measuring the length of the curve that goes between the starting and ending points. Very often it's going to be useful to parameterize a curve with respect to arc length. Arc length is a natural feature of a curve and has nothing really to do with the coordinate system or the parameterization. If we start with a curve, r of t, and then s of t is the arc length function that we previously defined, then we might be able to solve for t as a function of s. That is to say, t equals t of s. Then we can reparameterize the curve in terms of s by just substituting for t. So the important feature of a curve parameterized by arc length is that the parameter values tell you distance along the curve. If r of s is parameterized by arc length, then the length of the curve, r of s, where s goes from a to b, is just b minus a. The difference between the parameter values is going to tell you how far you've gone along the curve. Not all curves have this feature, and it's going to be useful at times to have a curve that's parameterized by arc length. Okay, that's all for now.